I've been asked to speak on plaque progression and destabilization. I think as an interventional cardiologist, we are just treating disease when it's already volcanoes erupted. So can we do something else for better understanding of plaque? Because we've been treating through a living person. Only way to look at the disease has been an angiography, which is a luminogram. But now we need to understand the disease better to have great success and prevent more events. Process of progression of coronary artery disease from mild to moderate stenosis or moderate to severe stenosis is called plaque progression or destabilization. Studies have shown that 1/3 of plaques have rapid progression and 2/3 of plaques have slow progression. What do you mean by rapid progression? There's no universal definition of rapid progression of atherosclerosis. However, most studies describing the phenomena have used the following definition. More than or equal to 10% diameter reduction of at least one pre-existing stenosis of more than or equal to 50%. Means a lesion which is 50%, if it increases by another 10%. Or more than or equal to 30% diameter reduction of a pre-existing stenosis which was less than 50% in stenosis previously. Progression of a lesion to a total occlusion, all these within few months is called rapid progression. Now, what is slow plaque progression? Similar events occur but over a period of years, not months. And then third thing is no plaque progression. We know what it means, no progression. The central illustration, when you look at the mechanism of rapid plaque progression, either there could be a lipid-rich plaque, that yellow thing you can see, because the accumulation happens abluminally first, and then it's covered by a fibrous cap. When there is either erosion or rupture of that cap, the contents come in contact with blood and forms a subclinical thrombosis, which eventually heals to form a new layer. You can see that on OCT. When this layered plaque, this is called layered plaque, this layered plaque can again become unstable, leading to a thrombus formation and again new intima formation on top of it. This is called plaque progression or destabilization. So when we do an imaging, can we predict plaque progression? We all know that coronary angiogram is extremely poor in predicting plaque progression. Intracoronary imaging has a great potential in helping us to predict the plaque progression. Various studies have mentioned about few key factors I will enumerate which can predict the plaque progression. Which are these? Most important is thin cap fibroadenoma called TICFA, then lipid-rich plaque when you look at the arc, and lipid arc of more than 180 degrees, sorry. Macrophages within the plaque, microvasculature, if there's, and then you have a layered plaque. All these are predictors of unstable plaque or one which can become soon unstable. That's called intraplaque hemorrhage. My colleague just now showed certain intraplaque collections which could be intraplaque hemorrhage, which are high indicators of future events. Now, if you see here, the arrow which faces, the golden yellow ring between 5 o'clock and 9 o'clock seems to be quite thick and bright, but between 12 o'clock and 4 o'clock, it's very, very thin. And all around, the light is not penetrating at all without any another layer of shadow. That means it's very, very lipid-rich and very thin fibroatheromatous plaque. Plaque is the savior. As long as plaque is thick and stable, the chance of ruptures are very less. At best, at worst, there can be an erosion. Next is the layered plaque. You can see here in these arrows is the previous external elastic lamina, and then there is some plaque and there is another plaque here. How do you know? The light reflecting characters are going to be different. Compare the first one here to here. There are two different layers of different light reflection. So this is layered plaque, which is more vulnerable. Now you can see a actually this is slightly big. It's much smaller microvasculatures. This I try to get out of my own images. On book there are better ones. If you find new vasculature within the plaques, then they are vulnerable for hematoma formation and ruptures. And then the lipid arc. Here, if you see between 6 o'clock and 12 o'clock, all of that is dark and covered. That is, more the lipid arc, more the chance of plaque rupture. And then look at the lipid content. Higher the content within the plaque, which is primarily lipid, not fibrotic, not calcified, then the higher risk of that causing inflammation and destabilizing the cap and then eventually leading to plaque rupture. Then the macrophages. Just behind this golden intimal layer, you can see there are bright spots which are actually macrophages. Macrophages, if they're clustered together, they cause more inflammation, more destabilization of the plaque, and more chance of plaque rupture or erosion. And then this, we just saw a picture like this. This is called intraplaque hemorrhage, which again is associated with high risk of ACS. Now, is there any clinical evidence for this? The CLIMA study, the relationship between coronary plaque morphology and LAD, 12 months clinical outcome. Here they measured three things: minimal lumen area of less than 3.5 millimeter square, then fibrous cap thickness of less than 75 micrometer, very, very important. Fibrous cap thickness of less than 75 micrometer, and then lipid arc circumference of more than 180 degree and OCT defined macrophages. If all of them were there, you can see this fibro cap thickness, if it's less than 75, if it is not there, if the event rates were 17%, if there is a fibrous cap thickness of less than 75, that is TICFA, the event rates become 51%. Similar, minimal lumen area is not greatly correlated. Lipid-rich arc is again good indicator. But when you combine 2-3 of them, FCT, MLA, and lipid arc and macrophages together, look at the last columns. If all 4 are present, the risk of plaque events goes up by 18% compared to just 3%, means 6 times more if all 4 are there. So when you image a plaque, try to look at all of them. Due to paucity of time, I'm just rushing forward. What is important is they have great negative predictive value. Look at the last column. Yeah, this is where you need to look at it. The negative predictive value is close to 97%, 92 to 97%. If there is a minimal lumen area of more than 3.5, don't bother. Minimal cap thickness more than 75, lipid arc less than 180, no macrophages, cholesterol crystals, calcified nodules, then event rates are going to be very, very less and you're pretty reassured. In the other study, predictor of rapid plaque progression, 517 lesions. Again, when you look at it, lipid-rich plaque increases by about 1.5 times. TICFA increases by more than 300 times. TICFA is the most important thing, and then layered plaque. Now, this couple of cases I'll just show you. You can see here, it looks a very innocuous plaque in the proximal LAD. FFR was just 0.96. Only FFR may not tell you the real story, and you know that you need to really get aggressive. Here, if you look at it, quite thin plaque. The many areas, the plaque thickness is quite thin, and there's quite a bit of lipid arc. You can see almost 360 degree there. And when you come in certain areas, I'll show you, you will start seeing now. I'm so sorry. Okay, it's moved. I can't go back. You can see here intraplaque vasculature. You can again see a layered plaque here. There is again a hematoma. That's like, big collection of part of calcium and then lipid rich. The arc is more. All these are important to understand. This is a second case, mid RCA. You can see here when you do an imaging, quite thin thin cap, but some of it is thick and good. But as you start coming in, see here, you will realize that all is lipid rich. Although cap is thick, the whole plaque content is lipid rich. So these are the ones which are highly vulnerable. You can see here layered plaque again. Now you can see a lot of mix of cholesterol crystals. I'll show you when I freeze. Again, a lot of vasculature. So let's go to the next slide. If I can show you. It's not moving. Okay. Now you can start looking at the vasculatures there. They can anytime rupture and cause plaque destabilization. That's a layered plaque you will see there. And then again, you're seeing here a calcium nodule and again a small hematoma. This is a third case. So this is, I know, I will finish very quickly. So when you look at something like this, imaging gives you a great deal. Here, this gentleman had the inside the stent ISR. You can see that it's a neoatherosclerosis, and there are quite a bit of macrophages too. Okay. Eventually, to conclude, what I would like to tell you, this is another image of TICFA, and take-home message would be that angiogram is not enough to take the right decision in majority of the cases, especially if you think the disease is diffuse. Coronary imaging helps in avoiding unnecessary stenting and in taking right decisions. Third, when you are in doubt, do imaging. It adds a lot of clarity knowing what is the pathophysiology, what is the kind of stent, whether you need high pressure, low pressure, what should be the plaque modification, would you need a cutting balloon, rotablation, OPNC, or even a lithotripsy balloon. And all cath labs should have at least one imaging modality as we progress. You need to incorporate an imaging as a part of cath lab investment rather than hoping that, we will call for it on a case basis. Do not hesitate to do a preventive angioplasty if required when there is, about 50 to 70% plaque, but very highly lipid-rich, intraplaque hematoma, and then FFR is very borderline 0.82 or something like that. Thank you.